Good morning, everyone. How are you doing? Hello, how are you doing? I mean, I walked into this place and I went like, holy cow, what an event. So what I wanted to do is to ask all of you to give the Data Innovation Summit team a big applause for organizing such a fabulous event. Let's start with that. Woo! What an incredible place to be. I'm so excited to have 20 minutes, actually 19 minutes and 40 seconds with you now. But what I wanted to talk about is where AI is going. Because we all know what happened with AI, right? You bring all the data to a central location, and then you use your GPUs and all your advanced infrastructure to do all the training, and then you get the models that you think are good, and then you distribute them to wherever they need to go in a static, non-changing format, because you've proven the thing in a centralized fashion. And I think that that's great, but I don't think that that's where the world is going. Where I think the world is going is from offline, centralized ways of working with AI to online and decentralized or federated ways of working. And why do I think that? Well, there are a number of reasons. The first is, if you are a European and you look at the European industry, you probably understand that all of us are very much involved in embedded systems. If you look at cars, if you look at telecom systems, if you look at mobile phones, if you look at other devices, we have millions of instances of these products out in the field. All of these products have a lot of computational power, they have data storage capabilities, but we are not making use of any of those capabilities that we have at systems in the field. So in order to make use of that, we need to not only move the inference, so a static model out on the edge, to the edge. No, we have to actually move the training out to the edge as well. We have to get to a point where systems are continuously training themselves and are continuously improving themselves over time. And in order to be able to do that, we need to move from centralized, offline ways of working with AI to online and federated ways of working with AI. And that's what I wanted to talk with you about in the coming 17 minutes and 45 seconds. Is that okay? Is that a good topic? You want to know more about that? Yeah, are you sure? I have other presentations, but they're on my other computer. Yeah, so what I wanted to do is briefly tell you who I am and where I come from, then spend a minute on this concept of digitalization, which I think is quite important. Then talk about what I believe are the challenges of centralized and offline AI. Move towards explaining and talking a little bit about what federated and reinforcement learning are all about. Give you some examples that one of our PhD students, Hong-Yi Zhang, is working on, and then move to conclusions. So very briefly about me, I used to be a young and innocent professor of software engineering. Then I went to work for Nokia. You remember Nokia? Yeah, it was a fun company, right? Well, as good as long as it lasted, and then it stopped. Then I moved to Silicon Valley. Now I do a whole bunch of other things, among others angel investing. Come and talk to me if you're starting a company. And according to my PhD students, I'm now an old, grumpy, and cynical professor of software engineering, as you can tell, right? But the main thing that I do is I run something called Software Center. Software Center is a collaboration between, I think, 15, 16, 17 companies and 5 universities. Typically large companies. Some of you may actually be working at the companies. For instance, Grundfos, I know that some of the people from Grundfos are here. And the focus of Software Center is to significantly improve the digitalization capability of the European software-intensive industry. And how do we define digitalization? We define it as software, data, and artificial intelligence. So that's what I do for a living when I'm not on stages like this. Then if we talk about digitalization, I think everyone talks about it, everyone has an idea about what it is, but for me, the essence of digitalization is a fundamental shift in how we deliver value to customers. Yeah, I often use my car. I drive an Audi A4 as an example. I've owned several Audi A4s, but every time I get the car, it is the best it will ever be throughout its entire economic life. And from that point on, it will get a little worse every day I use it, until I'm so sick and tired of the old clunker that I go and replace it with the next car. The next car is a little better than the previous one, but it still gets worse every day I use it. Digitalization fundamentally changes that proposition. The day I get the product, it is the best the company that sells it to me or offers it to me can make it, but it is also the worst it will be throughout its entire economic life. And from that point on, the system will become better every day I use it. And how does it do that? It does that by, for instance, pushing new software to it, improving the AI models in it, sometimes even periodically replacing the electronics in it, but the basic value proposition is every day my product is a little bit better than it was yesterday. That is the essence of digitalization. And that brings me to a general reflection on how do we deliver value to our customers. What I think is important to realize is that we have been on a journey where the speed and the frequency at which we deliver new value to customers is increasing at a constant fashion. We used to work in product generations. If you're in automotive, every 5 years there's a new platform, and the new platform provides new value to customers that the old platform didn't. Then we moved to yearly software releases. Anyone who has to work with the latest upgrade of Oracle or SAP or whatever knows what that is like. Once a year there's the new version. It's a huge pain in the neck to actually upgrade, so you have a few weeks of hassle, and then everything works and you move on with your life. Then we moved on to DevOps, Data Ops, ML Ops. And what we now have is a feedback loop where every 2 to 4 weeks there is new value coming out to people, to our customers. But it doesn't stop there. The next step is, of course, A/B testing. I give some customers A, some customers B. I measure which of these two is performing better in the field. And based on that, within a few hours or a few days, I can decide everyone gets A or everyone gets B. And now the last one, of course, at least the fastest that I know of, is this whole notion of reinforcement learning. What I do is I have elements of my system, certain aspects of the functionality, where the system fully autonomously experiments with its own behavior in order to improve the value that it provides to customers. And now I can get results or improvements within minutes or within hours. So we have a constant shortening of value delivery cycles, and that is the essence of digitalization. I have a complex model that in the interest of time I'm not going to go through, but if you're interested, come and talk to me afterwards. It also has an AI dimension at the top, where I believe that we're moving from static human interpretation of data to autonomous experimentation. It's too complex, but in general what we see is that companies that build software have 3 types of software development going on. The first is traditional requirements-driven development. Boring, but still necessary. Then we have what we call outcome-driven or data-driven development, where a team is basically asked to move the needle on a certain KPI. For instance, on websites, this is often conversion, but in other systems, this may be other metrics where a team is basically asked to go and experiment and try out different ways to move the needle on a certain KPIs. And of course, the last one is AI-driven development, where we use large data sets to train models that are then put in operation. If we look at how most companies that I work with are actually working, most of them are still stuck in a traditional requirements-driven way of working. They use hardly any outcome-driven way of working, and now some companies are starting to use the AI bit a little bit. This is where I think we need to be. We need to get rid of requirements to the largest extent possible. We need to become much more clear on what KPIs are we actually wanting to improve to deliver value to customers. And of course, we have to make more use of AI. So why am I so excited about events like the Data Innovation Summit? Because everyone here is concerned about making more and better use of data, which is exactly concerned with data-driven or outcome-driven development and artificial intelligence. Now we go to AI. I wanted to talk a little bit about what I feel are the challenges of centralized and offline AI. And for that, I will start with the very basic AI lifecycle. The hard part in AI is it's basically a 4-step process. I get the data, I create a model, or I improve the model, I train and evaluate, and then I deploy. And the interesting thing, which annoys me to no end about the AI community, is everyone and their brother is talking about models and about training and about results, as if that is the hardest thing in AI. And you know the interesting thing? All the companies that I work with, what is the hardest from an AI perspective is not the models and the training and evaluation. It is actually getting high quality data in trustworthy data pipelines and being able to deploy models in a way that is safe, reliable and secure, and that allows me to monitor the performance of the models, allows me to raise alarms, allows me to trigger automatic retraining of models, etc., etc. The hard part is not the model, the hard part is everything else around it. That's the hard part. And we worked on that because we developed a concept that we called AI engineering. There's actually an academic conference that I happen to be the general chair of, kicking off on Monday next week, where we basically put a research agenda together of all the challenges around the machine learning or deep learning model that need to be in place in order to successfully deploy machine learning and deep learning models in an operational context. I have a whole bunch of PhD students working in this. If you're interested in any of this, come and talk to me afterwards, as I said earlier. But the challenges that I see of offline and centralized training is a couple. One, we have millions of embedded systems in the field, and the European industry is especially strong in the embedded systems world. What I see is that all these devices in the field are collecting data, but the communication and storage costs are so high if you bring everything to one location, that all the companies that I work with are working really hard at limiting the amount of data and filtering the data that is basically pushed to the cloud because of cost reasons. So what I run into is a situation where the amount of data that I have available in a centralized offline context is actually quite limited. Even though I may have terabytes of data, it is still a fraction of the data that I have available to me in the edge. Yeah, so what I'm looking for is that we are now training machine learning and deep learning models on a highly limited, highly curated set of data, because the amount of data that is available through all our devices in the field is simply too large and too expensive to all bring to the cloud. So what we need to is to find ways to work in a much more decentralized fashion than what we're doing in the past. And not only that, if I have a central model and every device in the field gets the same static model, it is unable to adjust itself to local circumstances, and it can't do the mass customization that we're looking for, where my car, for instance, in the adaptive cruise control feature, adjusts itself to the ways that I like my adaptive cruise control to work. I want it to not work like everyone else. I want the bloody thing to adapt to me. Now, for all of you that have adaptive cruise control in your car, you know that training does take place, but you are the one training yourself on how to effectively work with the adaptive cruise control system, whereas I want the system to adjust to me, not the other way around. And of course, one of the big challenges is as well that data privacy and security is a major issue if you bring everything to a centralized location. So what I believe is that we have a tendency to copy AI approaches that work well for systems, software as a service solutions, so cloud-based systems, to the embedded systems world as well. And I believe that that approach is not optimal for software-intensive systems where we have many copies out in the field. So very quickly, because I'm starting to run out of time, but what I wanted to spend is a few minutes on the concepts. I guess all of you are quite aware of it. But in the case of federated learning, what we're basically doing is inverting the flow of what is actually being distributed. So in a traditional system, as I mentioned, you have edge devices. They are pushing all their data to the central location, and then the model gets distributed to the systems on the edge, so to the edge devices, and I do all the training in the center in a centralized location in an offline fashion. In federated learning, what we do is we basically do local training using the data available to us, and then we distribute model updates to a global model that then gets aggregated, that then updates an update of the central model that is then distributed again out to the edge devices. And this is an interesting thing. The edge devices don't have to take the model update. They can actually compare their local current model performance with the central model's performance. And if the local model performs better, the edge device can actually reject the new model. So we have a way in which you can start to see a deviation of models in the field because systems adjust themselves to the local circumstances. So we have a number of benefits of this. Of course, this is data privacy preserving. Even in high security situations where companies don't want to share their data, you can do the training locally on the company's premises and only share the model updates with each other so that every company that is willing to share model updates can still benefit from an improving model, but they never have to show or share their data, which I think is a very valuable one. Second, most embedded devices or edge devices actually have a lot of excess computational resources that are not used all the time, so we can make use of that. We can have fast deployment of things, much smarter models, and we have enormously much lower bandwidth needs in order to make this happen. Now, federated reinforcement learning, I guess you all know how this works. This is online. The system basically observes its environment, and then based on that decides to take an action that influences the environment. It gets a reward based on that, and the idea basically is for the system, for the agent, to maximize the reward. So rather than having a data set and then training a supervised model, what you do is you have a system that basically experiments in its own behavior in order to get better. If you combine these two concepts, what we run into is what we call federated deep reinforcement learning, which is one of the examples that I'm going to show you in the coming slides, where what you do is you give every edge device a deep reinforcement learning model, and you do the same model updates, model distribution pattern that we have with federated learning, and then you can actually have a situation where you can have hundreds, thousands of millions of devices all training concurrently and sharing the wisdom of what they've learned with each other so that everyone gets better at the same time. I believe that this is where the future of AI is going, especially in this software-intensive systems world. Some examples. We started this many years ago with one of our former PhD students, David Isamatos, with a Swedish telecom company that shall remain unnamed, where we basically went through the model of dynamically and automatically adjusting parameters in a base station in order to minimize connection time and maximize the number of network elements or mobile devices that could be connected to a base station. This is many years ago, and we had a multi-armed bandit approach that I can show you here, where we basically were looking in a kind of reinforcement learning approach for the best settings in this particular context, for this particular base station with this set of network elements or UEs. So that was one case. Another case is that we looked into a steering wheel angle prediction, where we had simulated together with a Swedish car company that shall remain unnamed, but I think you have a guess, where what we tried to do is we tried to do real-time, end-to-end federated learning with an asynchronous federated learning algorithm, where we were able to use multiple instances of the same system using different data to learn basically collaboratively what is the best steering wheel angle prediction that we were using. I am almost out of time and the thing is starting to blink. Then with another company, also a telecommunications company, we started to look into flying base stations. So how do you optimally position a flying base station to optimize the backlink and the uplink for those of you that use telecommunications? So this is a system that is in real time adjusting altitude, position, and antenna angle in order to optimize throughput. And of course, we had to expand that scenario to multiple UAVs or multiple base stations where you have multiple flying base stations that are jointly, collaboratively adjusting position, altitude, and antenna angle in order to optimize things. And that leads to wonderful results that I don't have the interest in time to show you. But interestingly enough, we actually got much better results with this algorithm than with any of the other approaches that we had been using before. Conclusion, 14 seconds. Yeah, this guy got it almost right. George Colony, former CEO of Forrester Research. In the future, all companies will be software companies. In the future, all companies will be digital companies. Software, data, and AI. And then the final things, and I'm out of time. Key differentiator in Europe is embedded systems. To build on that, we need to move from offline and centralized to online and federated. If you want to learn more, send me a mail at jan@janbosch.com and I send you free PDFs of all those books except the one in the upper left. And with that, thank you very much for your attention. I really appreciate it.